Hi everyone. So today we're going to go over the real number system. So in order to follow along today, you are going to need to have open your real number system notes. So if you don't have that open yet, go ahead and open up the real numbers notes from your Schoology. Go ahead and pause and open that up, and then when you're ready to begin, you can click play. Okay, so here in the real number system, we're going to go over these notes with you all, and so you guys get a better understanding of what it means to use the real number system. So we're going to make sure that we're writing in that objective for today. Okay, so your objective is going to be that I can identify rational and irrational numbers using the real number system. Okay. All right. So make sure you write that objective in. If at any point I'm going too fast, remember you guys can just pause and catch up and then continue your video. Okay. Okay. So the real number system is divided into two main categories, rational and irrational. Okay. So we're going to put real number system here. I'm going to just abbreviate number with the number sign. The real number system is divided into two categories, rational and irrational, right? Those are the two categories we're going to be working with. Okay, so what are those two categories? So rational numbers is going to be our first category here. Rational numbers are numbers such as 1/2 and 1/3 that can be written as a ratio of two integers. So what is a ratio, right? Or what does that look like to you? 1/2 and 1/3, they both look like fractions. Okay, so a rational number is a fraction or anything that can be written as a fraction. So remember, any whole number can also be written as a fraction, right? If I have the number 2, to make it a fraction, I just put 2 as the numerator, and then I put the fraction bar, and under that fraction bar, I put a 1. So that 2 over 1 is now a rational number, but it still represents my whole number that is has a value of 2. Okay, and the other category are irrational numbers. Okay, so rational means that I can write it as a ratio, or I can write it as a fraction. Irrational means that I cannot write it as a ratio, or I cannot write it as a fraction. Okay, so our rational numbers include numbers that are integers, and we'll go over what an integer is in a second. They are whole numbers, and they are also natural numbers, right? But again, they are in general just numbers that are written as a ratio of two integers, okay? So written as a ratio of two integers, that's what they are, right? Integers, whole numbers, and natural numbers are all examples, or they all include, are included in the definition of what a rational number is, because they can all be written as a fraction. They can be written as a ratio. Okay. We're going to keep moving along here in our notes. I'm going to erase everything I've written so far and move on down to the rest of my notes. All right, I'm going to pull that up. Okay, so integers, okay, integers are going to be any number that is a whole number that is not a fraction, but can be written as a fraction, and is not a decimal, and it includes the number 0, and it includes all negative numbers, okay? So your integers, I'm just gonna write some examples of what an integer is here in this box. I'm just gonna write an example of what an integer is. So integers could be anything from a -3, for example, would be an integer, right? -1 would be an integer. 0 would be included in an integer. 2, 3, right? Any of those numbers can be considered integers. Integers just cannot be decimals, they cannot be fractions, but they can be any number, negative or positive, that is whole, and that also includes the number 0. Okay, so integers are any positive or negative number. Okay, and so whole numbers are less inclusive than integers. That means they are more restrictive. So numbers that are whole numbers are also integers, but it doesn't go the same, it doesn't go back and forth, right? So for instance, whole numbers do not include any negative numbers. So I should say that integers are any positive or negative whole number, right? Because we don't want any fractions or decimals, right? But they can be written as a fraction, but not a number that has to only be a fraction. So it can't be 1/2 or -1/2. Those are not integers. But whole numbers include 0, okay, and any positive number, right? So everything else from 0 all the way up. But it does not include positive numbers, so negative numbers. So a whole number is any positive number that is not a fraction or decimal. And remember, this includes 0. 0 is part of this, right? 0 is included in what a whole number is. All right, so a natural number is, again, less inclusive than the category before. That means it's more restrictive. There's less numbers that are considered natural numbers than are considered whole numbers. So whole numbers are any positive whole number not including 0, okay? So it goes from 1 all the way up to any number we can count to or that we understand to be a positive number, but it does not include 0, okay? So it's any positive number, any positive whole number, right? Again, we don't want to just think about it as a number, but any positive whole number, so no fractions, no decimals, greater than 0. So 0 is not included in the definition of what a natural number is. Okay? So let's keep going with this idea. And we're going to do some more defining and definitions here. If you have any questions, go back and review this again. Just back up and make sure you're clear on my definitions, okay? And we're gonna just look at this chart here. We're gonna fill out this chart. So the real number system. So in this, we're just gonna include examples of numbers that work for any of these categories, okay? So within the real number system, we're gonna start from the smallest definition. So a natural number is any number that is positive and greater than 0, right? That is what a natural number is. So we're gonna include 619, that's an example of a natural number, okay? 4 is an example of a natural number, okay? A whole number includes natural numbers, but then it adds 0. 0 is also a whole number, but 0 is not a natural number, okay? Another example of a whole number would be 729. That's also a whole number, okay? So now integers include whole numbers and natural numbers, but now they add negatives. So negative 600 would be considered an integer, the same as 650 would be considered an integer, and the same as 3 would be considered an integer. Okay, so all of those are integers, but the negative numbers are not whole numbers, right? That's the new thing that we're introducing in this category is the negative numbers. All right, so rational numbers include all of these. They include integers, they include whole numbers, they include natural numbers, but now we also get to include fractions. So a fraction is considered a rational number, right? And so is negative. So our negative fractions, they are also rational numbers, okay? So these are examples of rational numbers. Anything that can be written as a fraction is considered a rational number. So not all decimals are rational numbers, but I can say that 0.25 is an example of a rational number because I can write that as 1/4. So it can only include decimals that can also be written as fractions. Okay, so that's what rational numbers are. Irrational numbers are numbers that cannot be written as fractions, right? Or don't have a fractional equivalent. So an example of that would be pi. Pi is an example of an irrational number, okay? Because we approximate pi as 3.14 or 22/7, but pi never ends, it just keeps going and going and going and going. So that is an irrational number. Another example would be the square root of 3, because the square root of 3 just keeps going and going and going and going and going and going. Okay, so that is an irrational number. Something that would not be considered an irrational number would be like the square root of -3, because that's actually an imaginary number. That number doesn't actually really exist. It's not a real calculation. So these are examples of irrational numbers because they don't terminate, right? They're not terminating decimals, right? And so they can't be written as a fraction. And so we estimate them, but they're not actually numbers that end in any real way, okay? So, and we can include irrational numbers as the negative equivalent of square root. So like negative square root of 2 would be considered an irrational number, but something that's not irrational would be the square root of -2, because you can't take the square root of a negative number. And so therefore that would not fit in this category of irrational. Okay, so those are your examples that you would need to think about when you're thinking about the real number system. All right, so your real number system really divides numbers into being rational, irrational. Rational meaning they can be written as a fraction, essentially, right? That's what you have to think about. And then we have different definition of rational numbers. Rational numbers include integers, whole numbers, and natural numbers. Your natural numbers are the narrowest category. The smallest amount of numbers fit in that pool, and that's every positive number greater than 0. Whole numbers are any positive number plus 0. It includes 0, and then we'll talk about what 0 is, because it's not really a positive or a negative number. And then integers are all whole numbers, which includes 0, plus it's all the negative versions of those whole numbers. And then rational numbers are fractions and everything else that we just talked about, okay? So that's what we're talking about when we're talking about rational numbers, and irrational numbers are numbers that we cannot write as fractions, okay, because they're non-terminating decimals. So we're going to move on to our next page of our notes. So let's talk about 0. And what's going on here with 0? So 0, right, what does 0 mean? Well, 0 means that you have a value, you have no value, right? So when you have 0, there's no value. Anything that's 0 is either free or there's no value associated with it, right? So 0 is neither positive nor negative. So that's 0, right? 0 doesn't have, it's not a positive number, it's not a negative number, it's nothing. It's just a symbol that we use to recognize nothing, that it doesn't have any value. Okay, so don't say that 0 is positive, don't say that 0 is negative, 0 is nothing. 0 is just there in the middle to separate the negative numbers from the positive numbers. Okay, so with that idea in mind, we're going to use 0 when we're on our number lines, and all of our number lines are crooked. I'm sorry, I added them and they came out a little weird on the PDF, and I apologize for that. But we're going to put the 0 here in the middle of our number line because this number line is asking us to graph these numbers, right? -3 and 2, -4, -7, 5, and -6. So if 0 is in the middle, if we think of 0 being in the middle between our negative numbers and our positive numbers, our negative numbers must always be on the left, and our positive numbers must also be on the right of the 0. Okay, because when we count, just like when we read, we count from left to right, and the numbers on the left have a lower value or are worth less than the numbers on the right. Okay, so we're going up in value if we go from left to right on a number line. So on the left is where we would put the negative numbers, and on the right is where we would put the positive numbers. Okay, so I'm going to leave everything like this here in blue, and then I'm going to change to red so we can compare our numbers more easily. So those are the things that are going to stay are in blue, and the things that are going to change are going to be in red. So the first thing I need to do is graph -3. So -3 is going to be negative, so it's going to be on the left, right? And so I want it on the left side of the 0. So I'm just going to count out about 3 spaces. Let's say 1, 2, 3. And I'm going to put my -3 right about here. It just has to be approximate and relative. So I'm going to say that this is where my -3 is going to be. All right, and now I have to graph a +2. I know that it's +2 because there's no negative marking in front of it. I do not need a marker indicating that a number is positive, but I do need a marker indicating that a number is negative. Okay, and if we see these in the future in an expression or an equation, if a number is followed by if a number is preceded or in front of it is a minus sign, I'm going to treat that number as being negative because it's really just being subtracted. Okay, excuse me. And so now I want to graph my 2. So I'm going to go onto the positive side of my number line. I'm going to count by 2. So I'm going to go 1, 2. I'm going to put the 2 right about here. Okay. And I'm going to do the same thing for the numbers in letter B, -4 and -7. So -4 should be 1 space to the left of -7, right? Because even though 4, it has a greater value than 3, when we're talking about negative, it's actually a smaller number than -3, right? So this is where -4 would go. And then I have to graph -3. So -4, -5, -6, -7 would be right about here. Okay. And I'm going to do the same thing with letter C. So I have to graph 5 and 6. Let's graph 5 and -6. So let's graph 5 first. So go 2, 3, 4, 5. And then -6 is going to be right about here. Okay. So if we look at this number line that's all filled in now, we see that -7 has the lowest value because it's furthest to the left, and +5 has the highest value because it's closer to the right. Okay. And so they want us to compare the values of each of these numbers, each of these number pairs. So what I'm going to do is I'm going to say that -3 is less than 2, because when I write this symbol this way, it means that the number on the left is less than the number on the right. The mouth of your symbol should always point to the number that has the greater value. And this is the mouth. The part that's open to me is considered the mouth. And that should always be trying to eat the bigger number, because when we're hungry, we want to eat more, right? So I think that's how that should work. And so now let's do -4 and -7. Which of these two numbers are bigger, -4 or -7? So -4 is actually bigger than -7, as we can see from our chart, right? Our -7 is all the way on the left, the 4 is more to the right, the number more to the right is bigger. So that means I should say -4 is greater than -7. All right, and then the last example here, we have 5 and -6, okay? And again, 5 is gonna be greater than -6. Okay, so we're gonna take a look at absolute value now. So we're gonna switch it up. I'm gonna clear these notes so that we can move on my PDF here. I'm gonna scroll down. Okay, all right. So when we're looking at absolute value, what does that mean? What is absolute value? All right, so the absolute value of a number is just the number's distance from 0. So now we're not talking really about whether a number is negative or positive, but how far the number is from 0. Okay, so the absolute value of a number is its distance from 0. So the notation that we use for absolute value are these 2 bars here. Okay, so we're going to use a number line so you can demonstrate, so I can demonstrate to you the value of these 2 things using the absolute value number line. So I'm going to just put it in 0 here. I'm going to put this in here for 0. And then I'm going to just going to mark these numbers on this number line. And then we're going to look at the value of them. Okay. All right. So first we're going to do 5. So again, I'm just going to count 1, 2, 3, 4, 5. And I mark my 5 right about here. And then 8, 1, 2, 3, 4, 5, 6, 7, 8. We'll put the -8 right about here. All right. So I mark the numbers without the absolute value marks. All I want to show you right now is how we determine absolute value. The absolute value is just the distance from 0, right? So what we're going to do is just count the number of spaces from 0 to each number. So from 0 to 5, we have to go 1 space, 2 spaces, 3 spaces, 4 spaces, 5 spaces, 1, 2, 3, 4, 5. So the absolute value of 5 is 5. What about the absolute value of -8? The absolute value of -8 is 1, 2, 3, 4, 5, 6, 7, 8. I have to do 8 jumps to get to 8, so that's the absolute value of -8. It's just 8. I just have to count those jumps. 1, 2, 3, 4, 5, 6, 7, 8. That's really all we're doing when we're determining absolute value. And when we work with more math with absolute value, there's going to be a whole separate lesson on how to really calculate this. But I just want to get you the idea for what absolute value is just trying to determine the distance of a number from 0. If that number is a negative number, well, how many numbers are in between itself and 0? That's really all you're counting. You're not counting, you're not trying to figure out anything else when you're just determining the absolute value of or something, okay? We have to do math with it, we'll do more calculations, and it will be a whole separate lesson on absolute value. This is just a quick little introduction, all right? So with the same idea in mind, we're going to be able to find the opposite of a number. So the opposite of a number is the same distance from 0. So both numbers have the same what? What do they have the same? The same absolute value. Okay, so to understand that, I would say that the absolute value of 5 is equal to the absolute value of -5, right? Because to get to -5, which would be about here on this chart, right? Oh, nope, sorry, I didn't count right. Here on this chart, it's 1, 2, 3, 4, 5 spaces, just like it's 1, 2, 3, 4, 5 spaces to 5. So they have the same value. Okay, so we're going to mark that out on this number line down here. So we have 0. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And do the same thing with my negatives. 1, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, and -11. Okay, so we're going to identify those places, starting with letter A. They want us to figure out the opposite of +2, right? If +2 is here, what's the distance for 2 from 0? It is 1, 2 spaces, right? So what is 2 spaces to the left of 0? 1, 2, it's just -2, right? So the opposite of 2 is, of course, -2. And what's the opposite of -11? Well, -11 is 11 spaces from 0. So what's 11 spaces to the right of 0? Well, of course, it is +11. So the opposite of -11 is 11. Okay, so that's why it's important to have this quick lesson about absolute value, because when we're talking about absolute value, we're also talking about the exact opposite of a number. So if I have a negative value like -5, the opposite of -5 would be +5. All right, thanks for sticking with me, guys. We only have a few things left to look at. We're going to look really quickly at this last part here of this page, and then we're going to do a quick little practice. Okay. All right. So real numbers in the real world. So what number would represent the following situations? So if we have a hawk that is descending at 150 miles per hour when striking its prey, well, we have to figure out what the word descend means. So descend, I can tell by this prefix that it probably has something to do with something going down. So if something is going down, how do I represent something that's going down? I usually use a negative. So it's going to be a negative or integer, right? Based on the fact that I have the word descends. And then I'm going to use the number that I have here, which is 150. So this is how I represent that, -150. All right, so now we're going to go to letter B. A skier wins a downhill race by skiing at 126 miles per hour. Again, it says downhill, so I know it's going down, and down I represent with a negative. And what's the number? Right, it's 126, so it's -126. Okay, just as simple as that. All right, we're going to keep going. We're going to look at this practice, and then we are done with these notes. Okay, so what we're going to do here is just sort these numbers into being rational or irrational based on the definitions that we discussed earlier. All right, so if you need to go back and look at your definitions, make sure you do that. But a rational number is any number that we can make into a fraction, and irrational numbers are numbers that we cannot make into a fraction. So it can be anything that can be a fraction. So any whole number can be a fraction. Remember that, okay? All right, so let's start with 0.8. Well, 0.8, right? 0.8 we can actually represent as a fraction. We can do 8 over 10, which is the same as 4 over 5. So 0.8 is a rational number. Okay, what about the square root of 64? Well, the square root of 64 is 8. So the square root of 64 is a rational number. 0, is 0 a rational number? It sure is. Okay, because it's a whole number and that fits inside that definition. Remember, I can write 0 over 1. 0 over 1 still has the value of 0. So 0 is a rational number. What about the square root of 32? Well, 32 is not a perfect square, right? 36 and 25 are perfect squares. 32 is not. And so this number comes out to a decimal. And so square root of 32 is an irrational number. Okay, we did those two. What about negative 19? Okay, negative 19, I can just do negative 19 over 1, and I have a rational number, so it's negative 19, goes right here. What about negative square root of 100? What's the square root of 100? Square root of 100 is 10, and the negative is not under the square root, so I can apply it after doing the square root. So what I end up with is just negative 10. And so yes, that is a rational number. So negative square root of 100 is a rational number. What about this? 2.343443444. Oof. Can I represent that as a fraction? It keeps going. It's non-terminating. That's what these little 3 dots mean. That means it's not terminating. So it's a not terminating decimal, so it has to be irrational. Let's make sure we copy it exactly correctly. There's a lot of 4s and 3s. Okay, so those are done. All right, what about pi? Of course, pi is my example of an irrational number, so that's irrational. 12 over 5, it's a rational number. All right. Okay, the square root of 121, square root of 121 is 11. So that makes the square root of 121 a rational number. 12.67 repeating. Again, it's another way to represent that it's repeating or non-terminating is by using that bar over the 7. So if it's non-terminating, it has to be irrational. Okay, what about 6 2/7? Well, 6 2/7 is just a mixed number. A mixed number can be considered rational, okay? We don't have to worry about the fact that it's a mixed number. It's a fraction, right? It's represented as a fraction. We can turn that into just a whole fraction just by multiplying and adding, right? 6 times 7 is 42. 42 plus 2 is 44. So we have 44 over 7. That's what that is, right? And so that's just the rational number. Square root of 75. So again, 75 is not a perfect square. 64 is a perfect square. And then the next perfect square after 64 is 81. So square root of 75 is not a perfect square. So it's not going to give us an even number. It's going to give us a decimal. That means the square root of 75 is an irrational number. All right. And then our last one is just 3 over 7. Right. And so 3 over 7, again, it's a rational number. It's a fraction. So that's perfectly fine and fits right in there. Okay, so you have now been introduced to how to sort rational and irrational numbers. You've gotten an introduction onto what the real number system looks like, and you should be prepared from here to discuss rational versus irrational numbers, but also how to use integers and what an integer is. So be prepared to continue to work with that. All right, so make sure you review these notes as you need to, and this video as you need to, and it'll always be up for you. All right, that is it for me.